All right, so what we're going to do is jump right into 2.5, and we're going to go over these 3 questions, and that's all we're doing on this section. Super easy. I don't even have any notes for it because we kind of already know everything that there is to know about this section. So part A says to make a scatter plot. Okay, so a scatter plot is simply taking the coordinates that they give you and plotting them on the XY plane. Now, what coordinates you're thinking? Well, this is an XY table, and an XY table is an input-output table, and it's also a set of coordinates, all right? You know what, even before that, let's begin with this. The X values are your input. Everybody write that down. The Y values are your output, okay? In addition to that, we need to start getting comfortable with the words domain and range. The input, which are your X values, that's also your domain values. So let me do this. Let me actually write down the word domain on the left side and put range on the right side. We don't need domain and range much on this worksheet, but on tomorrow's lesson and from here on out, we need to know that domain values are your input values, which are also your X values. The output values are the range values, which are also your Y values. Okay, so anyway, let's graph these, and be careful when you graph these. When you go to the coordinate 1, 1, you go 1 on the X, but if you go up here 1, it's going to be wrong because it's not going by 1 unit, it's going by 3 units. So when we say 1, 1, it's only 1/3 of the way up. So 1, 1 is really right here. And then 3, 5, 3 on the X, 5 on the Y, it's going to be right there. Next one, 4, 7, 4 on the X, 7 on the Y. Here's 6, 1/3 of the way up more. It's going to be right there, 4, 7. 6, 11, 6 on the X, 11 on the Y. It's almost to 12, so 2/3 of the way up from 9 to 12. And go ahead and plot the rest. So I just plotted 7, 12. That works out nicely because 12 is the actual Y value right there on the Y-axis. And then 8, 15 is right there. So hopefully you guys graph that. This last one, 10 question mark, we can't graph that yet. We will graph it later. But right now, what we need to do is take a look at these points, and we need to draw a line that best fits. Now up here on the instructions, they refer to it a line of fit, but other books say best fit. And I like best fit because you want to draw the line that most accurately fits all of these coordinates that you just plotted. So let me show you what I'm talking about here. I want to draw a line. Okay, and now see how this line passes through this first point and this last point, and it pretty much is a very good representation of all those dots using the first coordinate and the last coordinate. Now, what if I would have used, let's say these 2 coordinates? You guys see these 2 coordinates? Check it out. I want to use those 2 coordinates instead by moving my paper over. So if you used the coordinate 6, 11 and the coordinate 7, 12, it would produce that blue line, and that's not a good line that fits the data that we just graphed, is it? Okay, so it's always good to play with the different coordinates and see which one would truly give you the best one. Let's say we would have used the first point and this next point, the first and second point. Let's see what that would look like. Well, that looks a little bit better, but notice that the majority of the dots are below the blue line, right? So you got to keep playing, and obviously you guys don't have a nice perfect blue line like this. What you guys would use is probably the edge of your pencil, and you would take the edge of your pencil and move it around to different dots, like those 2 dots. This would be a pretty good line to use, right? But the dots that they use on the answers on the back side, if you read the back side, it says sample answers. It's using the first coordinate and the last coordinate. And if you do use that first and last coordinate, that works out nicely because it pretty much cuts the coordinates perfectly in half, right? So using the first point and the last point is a very good choice, and I highly recommend that, especially because that's what they use on the solutions on the back, this first one and this last one. So we've done part A. Well, almost all of it. It said do a scatter plot. Okay, we did a scatter plot. A line of fit, a line that best fits. We said that the first point and the last point produces that best line. And then it says describe the correlation. We could think of correlation as the slope. Okay, the correlation is the slope. And there's different types, or we could look into correlation differently. If it has weak correlation, that means that the red dots are like further away from the blue line, from your line that best fits. If it's strong correlation, that means that your dots are pretty close. But all they want is to describe whether it's a positive correlation or a negative correlation. So from left to right, is it going up or is it going down? It's going up, which means positive correlation, kind of like slope. So part A, we graphed the coordinates, we drew the line, and we're also going to say positive correlation. Correlation. I'm just going to abbreviate. So that's part A, okay? Let's move on to part B. It says use two ordered pairs to write a prediction equation. We actually already did that. We did our line that best fits using the first coordinate and that last coordinate, right? We said that that was a good line, so we use the first coordinate and the last coordinate. And part B is going to be taking the first and the last coordinate and writing an equation by calculating the slope and then plugging it into point slope form and then switching it to slope-intercept form. So let's do that. I want to do it over here on the side. You guys could do it wherever you have space on your paper. But anyway, if we really want to call this first point our first point, we're going to call it x1, y1. And this last one, we're going to call it x2, y2 for the sake of using the slope formula. And of course, when you use that slope formula, do your division bar and your subtractions symbols first. And then you could safely plug in your y2 value, which is 15, your y1 value, which is 1, your x2 value, which is 8, and your x1 value, which is 1. And if you do the math, up on top, you're going to end up with 14. 15 take away 1 is 14. And on the bottom, 8 take away 1 is 7. And what is 14 divided by 7? 2. So we worked out the slope, and it worked out beautifully for us. The slope is 2, and we could call it 2 over 1 if we want. But the fact is, we now have a slope, right, using the points that we used for our line that best fits. Now, we have a slope and we have some points. So what form would be good to use? Point slope, right? So we have points, we have a slope, let's use point slope. What is point slope? Y minus y1 equals m parentheses x minus x1. And again, I recommend whenever you use this to leave the blank spots so you could plug in your values safely. So the y1 value was from our first point 1, 1. So the y1 is 1, the x1 is also 1, and the slope we found out using the slope formula is 2. So this is our prediction equation, but let's change it to slope-intercept form because it's nicer. So let's distribute 2 times x, 2x. 2 times negative 1 is negative 2. Bring down the y minus 1, the equal sign. My final step would be to add 1 here, add 1 there. So I'll get my final slope-intercept form equation, which is y equals 2x minus 1. Ladies and gentlemen, that is our slope-intercept form equation, and that's the equation that represents this line that best fits that we drew according to our scatter plot. Now, part C, it says use your prediction equation. This is the prediction equation in slope-intercept form to predict the missing value. So right here there's a 10. What's the missing value? We need to find that out. So remember, an XY table is really an input-output table. It's a domain range table. So what this is saying is if you put in, because 10 is the input, if you put in the 10, and where are you going to put in the 10? On your x's, because the x's are your inputs. Put in that 10 right in there, and then do the math. What's 2 times 10? 20. And then what's 20 take away 1? 19. So the input 10 gave us the answer, the output, the y value, 19. See how it says y equals 20 take away 1 is 19. So that missing y value is 19. The output's 19. That belongs right in there. So we did all three instructions on this question number 1. So I'm going to stop right there. There will be a video uploaded explaining all of them. Okay. So but I just wanted to re-explain the first one as best I can. So if you got that down, the answers are on the back. You should be able to do the rest. If you want to see the other ones, you could watch the other video.